So now we'll be talking about atoms and the atomic theory. Remember, don't trust atoms, they make everything up. So let's start off with John Dalton's atomic theory, which he wrote in 1809. So it has 4 caveats. The first one is, atoms cannot be created, destroyed, or broken down any further. The second is that atoms of one element cannot be converted into those of another. The third is, atoms of one element can have the same physical properties. And atoms combine in specific ratios to form compounds. You'll see later on that the first 3 were debunked, whereas this one still stands. Our modern view, though, says that the smallest particle of an element that still retains the same properties of that element is the atom. That means if I have one atom of gold, that atom of gold still retains all the properties of gold. But if I break it down any further, I can't observe those properties. The next is that atoms are composed of 3 subatomic particles. Protons, which are denoted P+, for their positive charge. Neutrons, which are denoted N0 for their neutral charge, and electrons, which are denoted E- for their negative charge. So this over here goes to show that atoms cannot be created, destroyed, or broken down any further is wrong, because you can break them down into protons, neutrons, and electrons. So next we're moving on to the arrangement of the elements on the periodic table. So the periodic table is arranged by atomic number. That means that if you take a look at the periodic table, you'll see that they're arranged starting with hydrogen as number 1, number 2 is helium, number 3 is lithium, and so on. It also happens that the atomic number is the same as the number of protons in one atom of that element. So, if I have element number 5, it has 5 protons, and on the periodic table you'll see that element number 5 is boron. So, boron can be written like this. So B is its symbol, 11 is the mass of this specific boron that I'm taking a look at, and 5 is the atomic number. This blank over here, usually we don't write it, there's nothing over here, unless there's a charge. So if there's a charge on this atom, we'll get to that in a second, then you would have to write it over here. So let's first talk about atomic mass. So the atomic mass can be calculated very simply from just adding the number of protons and the number of neutrons. Because protons and neutrons make up the mass of the atom, not the electrons. The electrons have negligible mass compared to the protons and neutrons. So, because the mass is 11 in boron, that you can find out on the periodic table, you have the protons plus neutrons give you 11. You know that you have 5 protons because boron is element number 5, therefore it has 5 protons. So, simple math tells us that we have 6 neutrons. Because there's no charge in here, that means my positive and negative charges must be balanced, and like I said earlier, protons have a positive charge, whereas electrons have a negative charge. Because we have 5 protons, we must know that we also have 5 electrons. That gets a little hazy when we're talking about ions and isotopes though. So ions are created when you change the number of electrons in an atom. So if I were to take away 1 electron from this, it wouldn't have 5 electrons anymore, it would have 4, and it would gain a +1 charge, which I can just put over here as a plus. Isotopes are also different in that they have different numbers of neutrons even though they're still the same element. So, if you had boron 12, that would just mean you had 1 extra neutron, so you would have 7 neutrons. So this right here is the periodic table, and like I said earlier, it is arranged according to atomic number, with hydrogen being number 1 and helium number 2, and it just keeps going. So a couple of things to point out. This will be a bit of a reminder from grade 10, but everything on the left-hand side of this staircase, so these purple-colored semi-metals, everything on the left-hand side is considered a metal, whereas everything on the right-hand side is considered a non-metal. These on the staircase goes like this. These elements on the staircase are semi-metals because they have properties of both metals and non-metals. A couple of things to note also about the periodic table is that atoms in the same group have the same number of valence electrons, and valence electrons are just the number of electrons in the outermost shell. So hydrogen, lithium, sodium, and so on all have 1 electron in their valence shell. You can tell the number of electrons in the valence shell by looking at the group number. So this is group 1. These elements all have 1 electron in their valence shell. This is group 2. These elements all have 2 electrons. This over here is group 3, 4, 5, 6, 7, 8. We'll come back to these guys in a moment, but recall that they're very special because they're the noble gases. They're called noble because they're inert, they don't react. There's a reason for that. Second is that atoms in the same period have the same number of shells. That would mean hydrogen and helium have one shell. So lithium to neon have two shells. And the next one would be sodium to argon have three shells, and so on down the periodic table. Over here, we have the Bohr-Rutherford model. So the Bohr-Rutherford model is just a way of drawing atoms, just so you can see where the electrons, protons, and neutrons are positioned. So the protons and neutrons are always in the nucleus of the atom. The electrons are shown orbiting the nucleus. The first shell will always have two electrons. So lithium, its atomic number is 3. And because it's neutral lithium, there's no charge over here. We know that it must also have 3 electrons. So we're going to put 3 protons in the middle, in the nucleus, and then 3 electrons in the outer shells. So the first shell, like I said, has 2 electrons, so one over here, one over here. We draw them opposite of each other because they're electrons, both with negative charges, both repelling, because you'll recall from grade 9, like charges repel. The next shell, because we only have 3 electrons, we used up 2 over here. Third electron must go in the outermost shell. Carbon over here is similarly drawn. It has 6 protons, because its mass is 6, must also have 6 neutrons, 2 protons in the innermost shell, and then 4 in the outermost shell to make 6 electrons. Also, a reminder about Lewis structures. Lewis structures just show the outermost electrons, so the valence electrons. So lithium has 1 valence electron, so we just draw lithium with a dot, that's all. Beryllium has 2, so 2 dots. Carbon 4, and fluorine 7. The octet rule explains why the noble gases that I mentioned earlier were so stable. When you have 8 electrons surrounding an atom, that is the most stable configuration you can have. So we'll see later on that these elements can form ions or make bonds to become more stable.